Right now, racing between Mars and the Sun, there's an object doing something that's making NASA scientists lose sleep. It's a chunk of material the size of Manhattan, and according to Harvard astrophysicist Avi Loeb, what we're watching might be the first documented evidence of alien technology performing a braking maneuver in our solar system. This isn't some grainy UFO footage or misidentified weather balloon. This is 3I Atlas, the third confirmed interstellar visitor to our cosmic neighborhood, and it just did something that has the entire astronomical community scrambling for explanations. The object already had what scientists call an anti-tail, a forward-facing plume that shot out in front of it like a cosmic brake light. Then, as it barreled toward its October 29th close approach with the Sun, it suddenly transitioned to a traditional tail streaming behind it. This anti-tail-to-tail switch sounds technical, but here's why it matters. If you were piloting a spacecraft from another star system and needed to slow down as you entered our solar system, this is exactly the sequence you'd follow. Fire your engines forward to decelerate, creating that anti-tail, then once you've shed enough velocity, shut down the engines or reorient for your next maneuver. The traditional tail takes over as solar radiation strips material from your hull. That's precisely what we just witnessed. Multiple observatories are tracking this thing in real time. The Nordic Optical Telescope in the Canary Islands captured the transition in September. The Gemini South Telescope in Chile provided the clearest images we've ever had of an interstellar object. And here's where it gets interesting. NASA's HiRISE camera on the Mars Reconnaissance Orbiter grabbed shots when 3I Atlas passed within 12 million miles of the red planet earlier this month. Those images would be the highest resolution photos of an interstellar visitor in human history, potentially showing surface details down to a few dozen meters. But NASA hasn't released them. They claim it's due to a government shutdown. But these photos have been sitting in a database for weeks now, locked away while scientists worldwide are desperate to see what this thing actually looks like up close. The composition of 3I Atlas is where things get genuinely bizarre. Analysis of the forward-facing plume revealed materials that shouldn't exist in nature. Spectroscopic data showed a nickel alloy that matches nothing we've seen in meteorites or natural space objects. This specific blend is something we manufacture on Earth for high-strength aerospace applications. Water, carbon dioxide, cyanide, those are expected from a comet. But a manufactured nickel alloy? That's not formed by natural processes. That's engineered. Scientists are trying to explain it away, suggesting maybe under extreme conditions in some distant star system billions of years ago, natural processes could create this alloy. But the more they dig, the less convincing these explanations become. Let's talk about when this object was born, because the timeline is staggering. 3I Atlas is between 7 and 10 billion years old. Our Sun is only 4.6 billion years old. This thing formed when the universe was young, when galaxies were still taking shape, potentially in a star system that burned out billions of years before Earth even existed. It's been wandering through interstellar space, surviving radiation, cosmic rays, and the deep freeze of the void for longer than our solar system has been around. And somehow, after all that time, it's still structurally intact, still active, still capable of producing these mysterious plumes. Natural comets, especially ancient ones, tend to be fragile. They break apart under thermal stress. They fragment when they get close to stars. But 3I Atlas has survived a journey that should have reduced it to dust eons ago. The discovery itself happened on July 1st, 2025, when the Atlas Survey Telescope in Chile flagged a faint object moving against the background stars. Within weeks, astronomers realized they weren't looking at a normal comet. The trajectory was hyperbolic, the unmistakable signature of something not bound by our Sun's gravity. It came from the direction of Ursa Major, travelling at 58 kilometers per second relative to the local stars. Not absurdly fast for an interstellar object, but fast enough to confirm it came from outside our solar system. Astronomers traced its path backward through the galaxy, and the results were mind-blowing. This object has been travelling for billions of years, possibly visiting dozens or hundreds of star systems on its journey. But here's what really set off alarms in the scientific community: the water production. At distances where water ice shouldn't be sublimating aggressively, 3i Atlas was spewing out 40 kilograms of water per second. That's like a fire hose on full blast at distances where the sun's heat shouldn't be strong enough to cause that level of activity. The explanation they've settled on involves the object's unusual composition, an 8-to-1 ratio of carbon dioxide to water, completely unlike any comet from our solar system. CO2 sublimates at much greater distances than water, so maybe that's driving the activity. But even that doesn't fully explain what we're seeing. The numbers don't quite add up, and every attempt to model this object's behavior requires adding more assumptions, more special conditions, more exceptions to the rules. The anti-tail first appeared in August when 3 Atlas was still about 2.5 astronomical units from the Sun. Material was being expelled forward, ahead of the object, in a way that defied conventional comet physics. Loeb and his team at Harvard ran the numbers and came to a startling conclusion. If this were a spacecraft using a propulsion system to slow down, the anti-tail is exactly what you'd expect to see. The exhaust plume would shoot forward as the engines fired against the direction of travel. Then, in September, right around the 2 AU mark, the anti-tail disappeared and a traditional tail formed behind the object. If you were programming an autonomous probe to enter a solar system, 2 AU would be a logical distance to complete your deceleration burn, far enough from the sun to avoid thermal damage to your systems, close enough that you've captured into a trajectory that will take you through the inner system. The brightness variations add another layer to the mystery. Comets typically vary in brightness as they rotate, different sides reflecting different amounts of sunlight. But 3i Atlas's brightness changes don't follow any predictable pattern. Sometimes it flares up when it shouldn't, dims when it should be bright. It's almost as if the object is tumbling chaotically or, and this is the uncomfortable possibility, as if it's actively changing orientation, maneuvering. Every natural explanation requires adding complexity, assuming unusual shapes or asymmetric outgassing or exotic rotation patterns. But if it's artificial, if it's actually changing orientation deliberately, then the brightness variations make perfect sense. Now we need to talk about the cyanide, because this detail hasn't gotten enough attention. 3i Atlas is producing unusually high amounts of cyanide compounds. Yes, cyanide exists in comets naturally, but not at these concentrations. Cyanide-based compounds can be used as rocket propellants. They're not the most efficient ones we use on Earth, but they work, and they're made of elements abundant in space. If you were designing a self-refueling interstellar probe that could harvest materials from comets or asteroids it encountered, cyanide chemistry would be a logical choice. Is that what we're seeing? Is 3i Atlas burning cyanide compounds for propulsion? The spectroscopic data is suggestive but not conclusive. One more anomaly in a growing list. What's even more unsettling is the pattern we're seeing with interstellar visitors. Oumuamua in 2017 accelerated as it left our solar system with no visible outgassing to explain it. Scientists eventually hand-waved it away by suggesting invisible hydrogen outgassing, but that required physics that pushed the boundaries of plausibility. Borisov in 2019 seemed normal by comparison. It looked like a regular comet, acted like one, had a composition similar to our own solar system's comets. Everyone breathed a sigh of relief. Maybe Oumuamua was just a fluke. Then came 3i Atlas with its manufactured alloys, impossible water production, anti-tail transitions and extreme age. 3 interstellar visitors in 8 years, and 2 of them are exhibiting behaviors we can't properly explain. The statistical implications are staggering. If we're detecting interstellar objects at this rate and they're this diverse, then our galaxy must be absolutely teeming with them. Millions, maybe billions of objects drifting between the stars. Most too faint or fast for us to detect. We're only catching the ones that happen to pass close enough and bright enough for our telescopes to spot. And if even a tiny fraction of those objects are artificial, probes sent by civilizations to explore neighboring star systems, then the galaxy could be full of alien technology, and we're just now developing the capability to see it. The International Asteroid Warning Network added 3i Atlas to their target list earlier this week. Not because it poses any collision threat. Its trajectory takes it nowhere near Earth. but because they recognize this as an unprecedented scientific opportunity. They're mobilizing resources typically reserved for potentially hazardous asteroids to track what might be humanity's first confirmed detection of alien technology. The careful language in their statement, a great opportunity for an observing exercise, barely conceals the excitement and concern in the scientific community. They know something extraordinary is happening. October 29th is going to be critical. That's when 3I Atlas reaches perihelion, its closest approach to the Sun at 1.4 astronomical units. The object will be subjected to intense radiation, up to 33 gigawatts of solar energy hammering its surface. If it's a natural comet, we'd expect increased sublimation, possible fragmentation, dramatic tail growth. If it's something else, this close approach could trigger systems we can't predict. Maybe dormant machinery wakes up under the solar energy. Maybe the heat provides power for some kind of transmission. Maybe nothing happens at all, and that itself would be telling. After perihelion, 3I Atlas disappears behind the Sun from Earth's perspective. For 2 agonizing weeks, we'll be blind to whatever happens during its closest approach. The object could fragment, could change course, could activate systems, and we won't know until it emerges on the other side in early November. NASA's Solar and Heliospheric Observatory might catch glimpses, but those images will be low resolution at best. We're going to be sitting in the dark, waiting, wondering what's happening to this mysterious visitor at the moment of its greatest trial by fire. When 3I Atlas reappears in November's pre-dawn sky, that's when we'll get answers, or more likely, more questions. Astronomers will immediately measure its trajectory, comparing it to predictions based on gravitational modelling. Any deviation, any acceleration or deceleration that can't be explained by solar radiation pressure or outgassing would be smoking gun evidence of artificial propulsion. The brightness, the spectral signature, the tail structure, everything will be scrutinized for changes. If the object looks dramatically different, if there's evidence of structural damage or fragmentation, that might support the natural comet hypothesis. But if it emerges intact, unchanged despite the solar bombardment, that resilience itself would be remarkable. The public reaction to all this has been strangely muted. Here we have a potentially artificial object from another star system racing through our solar system, and most people have no idea it's happening. Maybe it's alien fatigue. We've been teased with possibilities so many times that people have stopped paying attention until there's definitive proof. Maybe it's the complexity of the story. It's hard to explain why an anti-tail transition matters without diving into orbital mechanics and spacecraft propulsion. Or maybe it's that the implications are so profound that people simply can't process them. If 3I Atlas is artificial, it means we're not alone. It means interstellar travel is possible. It means we're being visited, or at least passed by right now. Think about what this object has potentially witnessed. If it's 7 to 10 billion years old, it formed when the universe was roughly half its current age. It might have passed through stellar nurseries where new stars were being born. It might have witnessed supernovae, planetary formations, maybe even the rise and fall of other civilizations. This object is older than our Sun, older than Earth, older than the complex chemistry that led to life on our planet. And now, by pure cosmic chance, our paths have crossed. For a brief moment, measured in months, we're sharing the same region of space with something ancient and mysterious. The emotional weight of this is hard to process. If it's natural, we're looking at a pristine sample of another star system, preserved in the deep freeze of space for billions of years. That alone is extraordinary. A chance to study materials formed under completely different conditions than anything in our solar system. But if it's artificial, if someone or something built this object and sent it on a journey between the stars, then we're witnessing evidence that intelligence arose elsewhere in the universe and achieved something we're only beginning to dream about. Either way, we're living through a moment that will be remembered as long as human civilization exists. Avi Loeb has been taking heat from his colleagues for publicly discussing the artificial hypothesis. They say he's being sensational, jumping to conclusions, damaging the credibility of astronomy. But someone has to be willing to ask the uncomfortable questions. Someone has to look at mounting anomalies and say this doesn't fit our models. Science progresses through bold hypotheses, even ones that turn out to be wrong. And if Loeb is right, even partially right, he'll be remembered as the scientist who first took seriously the possibility that we've detected alien technology. The conservative approach would be to assume it's natural until proven otherwise. But when the natural explanations require increasingly complex assumptions and special conditions, at what point does the artificial explanation become simpler? We're approaching a crossroads. In just days, 3 Atlas will swing around the Sun and begin its journey back to interstellar space. If it maintains its predicted trajectory, it will pass through the asteroid belt, cross Jupiter's orbit in early 2026, and eventually leave our solar system entirely, heading toward the constellation Lyra. We'll have a few more months to observe it, to gather data, to test our hypotheses. But once it's gone forever. This isn't like studying Mars or Saturn, where we can always send another probe. This is a one-time opportunity to study something from another star system, possibly from another civilization. The tragedy would be if we let it slip away without getting definitive answers. Those HiRISE images sitting in NASA's database could show surface details that would settle the debate. The November observations could reveal trajectory changes that prove artificial propulsion, or they could show that despite all the anomalies, 3I Atlas is just an unusual but ultimately natural comet. Either outcome would be scientifically valuable, but we need the data to make that determination. Every day that passes without full observation is a missed opportunity. What should we be watching for? First, any images or data that finally get released from the Mars encounter. Second, the perihelion passage on October 29th. Watch for unusual brightening, fragmentation, or unexpected activity. Third, the November re-emergence. Measure everything, compare it to pre-perihelion observations, look for changes. And fourth, the trajectory analysis. This is crucial. Any unexplained deviation from gravitational predictions would be evidence of propulsion. The universe doesn't usually announce its secrets with fanfare. The biggest discoveries often come from small anomalies. Tiny deviations from the expected, patient observation of things that don't quite fit. 3I Atlas might be just another comet with some unusual properties. Or it might be the most important discovery in human history, hiding in plain sight, disguised as a dirty snowball. The fact that we can't tell the difference yet is both frustrating and exhilarating. Somewhere between Mars and the Sun, that Manhattan-sized object continues its journey, oblivious to our speculation and debate. It's growing its tail, shedding material at rates that challenge our models, carrying its cargo of mysterious alloys and ancient ice toward a date with solar fire. In a few days it rounds the Sun. In a few weeks we might have answers, or we might have evidence that the universe is far stranger and more populated than we ever dared imagine. The telescopes are watching, the data is accumulating, and whether 3I Atlas is a messenger from the deep past or something far more extraordinary, we're privileged to be the generation that gets to witness its passing. The universe is about to show us something. The question is, are we ready to see it?